Hello, I'm Storm from the Dark, and welcome back to Analyzing Yu-Gi-Oh! Theory. Last time on Analyzing Yu-Gi-Oh! Theory, we looked at how running 3 Upstart Goblins in your deck affects the opening hand that you draw. I plan to have part 2 of this series look at how running 3 Upstarts affects your draw throughout the course of the duel. However, I found a mistake in the formula we came up with in part 1. So instead, this part will focus on correcting that mistake. We'll start by looking at how I realized there was a mistake in our formula. Then we'll go into correcting it, and end by looking at the new results the formula presents. If you haven't seen part 1 of this series, I recommend you go back and watch it first. It does a good job of deriving the formula we're about to look at. And although there is a mistake, because I left out something important in the formula, everything that I present in that video, up until the results section, is correct. So for a more detailed explanation of this formula, please refer to part 1. First, let's review the formula that we came up with last week. We base this formula off of the number of combinations, where n is the number of cards in your deck, k is the number of cards you are drawing, and the number of combinations is represented as n factorial over the quantity k factorial times n minus k factorial. Or for a 40 card deck in our opening hand of 6 cards, 40 factorial over 6 factorial times 40 minus 6, or 34 factorial. We said that we could get the percentage by looking at the number of good combinations. I defined this, for example, as us drawing Dark Hole in our opening hand. So the number of times that happens, divided by the number of total combinations for a 40 card deck, or 40C6. We could also calculate this number by taking 1, which represents the number of total combinations over total combinations, minus the number of bad combinations, or hands where we didn't open Dark Hole, over the number of total combinations. We also presented this idea of a theoretical 37 card deck, where we're basically running a deck with 37 cards in it instead of 40. The reason this is useful is because it gives us a baseline to compare a 40 card deck with 3 upstarts to. So to calculate the percentage of drawing our 1-up Dark Hole in a 37 card deck, we use this formula here. Similarly, we can use it in a 40 card deck with by replacing this letter n here with the number of copies of card you're running. So for Dark Hole, as used in this example, it would just be 1. We said that since this is the base percentage of you just drawing Dark Hole in your 40 card deck, we can represent the amount Upstart adds in 3 different ways. The chance we draw 1 Upstart is the number of combinations in this 5 slots, except for Dark Hole. You don't want to include Dark Hole with that, otherwise you get overlap with this. And then you multiply that chance of you having drawn the 1 Upstart by the chance that from off that 1 Upstart you'll draw into Dark Hole. So either you'll immediately draw into Dark Hole, you'll draw into a 2nd Upstart, then into Dark Hole, or you'll draw into a 2nd Upstart, a 3rd Upstart, and then Dark Hole. For 2 Upstarts in your hand, it's similar. The number of combinations for these 4 slots, excluding Dark Hole, and then you multiply by the chance that you draw into Dark Hole off those 2 cards, or if you didn't draw into Dark Hole, you draw into your 3rd Upstart off of those 2 cards, and then you draw into Dark Hole. And then lastly, for 3 Upstarts, just off of those 3 draws, you draw Dark Hole. We'll come back to where the error in this formula is in a minute. First, let's look at how I realized that it was an error. Here we have the number of total combinations for a 40 card deck in your 6 card opening hand. And here is the number of combinations in your 40 card deck. The total minus the number of combinations where you didn't open Dark Hole, for my example, gives you 575,757 out of the 3,838,380, which is a ratio of 0.15, exactly what we found last time for a 40 card deck. I also did this for our theoretical 37 card deck, and got a ratio of 0.16. It's actually 0.162, 162, 162, but for display purposes I just left it as 0.16. Then, we wanted to find the number of combinations you'd have to open Dark Hole in your 40 card deck to maintain the ratio of a 37 card deck. To do that, we took the total combinations and multiplied by 0.162 repeating. And that gives us 622,440. We subtract the total number of Dark Holes we already open in a 40 card deck, and that gives us a difference of 46,683. That's how many times we would have to open with Dark Hole off of drawing from our Upstarts in order to maintain the ratio of a 37 card deck. I then took our representation from the formulas of when the number of combinations where we draw 1 upstart, number of combinations where we draw 2 upstarts, and the number of combinations where we draw 3 upstarts. I multiplied by the ratio for when we would draw into dark hole, and that gives us this many times that we would for each of those cases. Add those up and we get 15,981. Not quite 46,683. In fact, it's the 65% error, or percent difference, that we found at the end of the last video. So that matches up, but here's the discrepancy occurs. If we add up these values, we get 443,037. And that's how many combinations where we opened Upstart, but we did not open dark hole. Is there another way we can calculate this value? Well, we can find it by taking the number of combinations where we didn't open Upstart. So 40 minus 3 is 37. Drawing 6 cards is this number. We'll subtract that from the total number of combinations, and the leftover should be the number of combinations where we do open Upstart. Right here. Another way to calculate the number of combinations where we open Upstart would be to take the number of combinations where we open 1 upstart plus the number of combinations where we open 2 upstarts plus the number of combinations where we open 3 upstarts. You'll see that these numbers don't match, even though it's calculated the same way we did in our formula. We can also take a similar idea to what we did in our formula and say that what's the chance of us opening upstart and dark hole, where we reserve 1 spot for 1 upstart and dark hole and take the number of total combinations in the other 4 slots for 2 upstarts and 1 dark hole, and for 3 upstarts and 1 dark hole similarly. You'll notice that this minus this is this, and those numbers don't match up, and this plus this number is this. These numbers don't match up. Anyways, this discrepancy means that something's wrong with our formula somewhere. So let's go back and see if we can figure out what that is. Well, it's bound to be here in this upstart section. In fact, if we look at this, you'll notice that we said the number of combinations we open with a dark hole off of upstart is equal, well, the number of combinations where we open with upstart, we excluded dark hole from this and said that basically these other 5 cards can be the other 36 cards in the deck. What we failed to look at though was this 1 upstart. This actually represents a combination as well. There are 3 different upstarts in our deck that could be this 1 upstart, and we're choosing one of them. So we should actually multiply by the combination 3C1, and here by 3C2, and lastly here by 3C3. We can also multiply the initial amount by 3C0. Basically, we're choosing 0 of our 3 upstarts to be in one of those slots. So let's calculate which of these values is. Let's start with 3C0. 3 factorial over 0 factorial, which is just 1, and then 3 minus 0 factorial, which is 3 factorial. So the 3 factorial on the top and the bottom cancels, and it's just 1. For 3C1, we went over last time that when you multiply by 3C1, it's actually just n, or 3. For 3C2, we can go back to our formula. 3 factorial over 2 factorial times 3 minus 2 is 1. So just 3 factorial over 2 factorial, which is, again, 3. And lastly, 3C3, there's only one way to choose all 3 of them. That's by choosing all 3 of them. But for the sake of doing the math, 3 factorial over 3 factorial times 3 minus 3 is 0 factorial. So 1. The 3 on the top and the 3 on the bottom cancel, and you just end up with 1. So all we have to do to fix the formula is multiply by 3 at these 2 locations. Let's go back. Oh, before I move on from this, note that here with the 2 upstarts, we treated this as 1 upstart drawing, and then 1 card here that's not dark hole as well. This is actually a combination as well, but there's only 1 upstart left in the deck for us to draw, and we're choosing 1. So again, it's just going to be multiplied by 1. So now we'll go back, we'll change our formula here. We'll multiply by 3. Multiply by 3. And now, the total number of combinations where we open dark hole is 46,683, the exact number we needed. there's a percent error of 1.5 about times 10 to the negative 12. It's really close to being the same thing. If we also here say that there should be 3 upstarts in this one upstart area, or a combination of 3C1 for 1 upstart, 3C2 for 2 upstarts, and 3C3 for 1 upstart, notice these numbers match exactly regardless of the way that we calculated them. Here, you have 3C1, and then the dark hole, there's only one way to calculate that, and that's multiplying by 1. 1C1, since there's only one copy of it in the deck. Similarly here, well, when we do that, these numbers match up regardless of the way you calculate them, either by adding these numbers or by doing this minus this. Also, this plus this now equals this. So all the math seems to work out now. Let's head over to where we ended last time, and we'll edit this formula, including a times by 3 at the start of the 1 upstart area, and for the term of the 2 upstarts as well. Now the percentage for 1 card, it matches exactly. There's an actual error of 7.1 times 10 to the negative 15th, and percent error of 5.84 times 10 to the negative 13%. We're looking like it's exactly a 37 card deck, actually. And that trend continues for 2 copies in your deck as well, and 3 copies. So we are, for all intents and purposes, running a 37 card deck. It turns out that Hopin's theory and my original hypothesis was correct. Before I end the video, I'm going to go over something I forgot to mention at the end of the last video. And that's that this formula is more useful than just comparing how a 1 of, a 2 of, and a 3 of, how those percentages change. You can also think of it as, what's the chance that, for example, in a Fire Fist deck, that I open with one of my 3 copies of Bear, or one of my 3 copies of Tenki, since I want to open Bear in my opening hand, since I want to see my opening hand, and I can get Bear off of Tenki. Well, if those 6 cards, the percent chance that you open with at least one of them, in a 40 card deck, it's about 65%. In a 3 upstart or 37 card deck, it's about 68%. You could also say, well, if I'm running 10 traps in my deck, what's the chance that I see one of them in my hand? Well, got an 87.267% versus an 84.5%. So you can actually look at it as saying, well, if I want to see one of these cards in my opening hand, what's the chance that I see it? Now, this can't quite be used to say, well, I want to know the chance that I draw this card and this card. We're not quite there yet, but that will be a topic for a future episode. Anyways, I hope that you enjoyed the video, and if you like the video and you like the series, please go ahead and thumbs up the video, like it, subscribe even if you want to see future episodes in your subscription feed. Thank you for watching. This has been Someone from the Dark with Analyzing Yu-Gi-Oh! Theory. Until next time, bye.